But anyway, so this is episode 19 of Following Mechanical Turks. So today what we're going to do is maybe talk about a few findings and where things might head from here. And then Nathaniel, you might chime in with some of the theoretical stuff, because kind of the way we had parsed it before, I was still working on working up the data, and then you were looking at kind of frameworks that might help us explain what we're seeing.
Yeah, just sort of working my way through things that seem either explicitly related or increasingly tangentially related, but that might somehow contribute to the sort of managing this thing that we're thinking through.
Yeah. Okay, so let me just sort of dive into it then, and let me share my screen over here. Screen one. Okay, so the first thing I wanted to take a look at is, as I mentioned, and I got really worked up about it last time, we were going to categorize the information, not starting with, okay, let's see if we can apply some kind of metrics to figure out what are the types of jobs, right? And we kind of looked at, using topic models or this or that, how could we knock it down into types of jobs so that we could then look at the different compensation levels in the aggregate for those different job types. But then we decided that's probably putting the cart before the horse, right? If we want to look at compensation differences, start with those compensation differences, which are a much cleaner break than trying to pick out, okay, well, what are the job types? And then how does that map to compensation? Just start with, okay, well, what are the different levels of compensation? And then see what's going on inside those. So that's what I did. And the way I broke it, let me see. Let me pull this up just so we're all on the same page here. Let's do processed. No, let's not do processed. Let's just pull this up. Okay, so just so we're on the same page here, basically the gist of it was, you've got the reward, and you're seeing this, right? Yeah, so you've got the reward and you've got the duration. And now the duration in seconds, it's not like that's, so that's a rough estimate for how long a particular post should take, right? Now, probably, there's some padding there, but at least it's a metric for, this is the sort of expected time this would take. So like what, this is 600, so it'd be what, 10 minutes, right?
Yeah.
I think that math holds up. And then you got the reward. So using those two numbers, you can get the compensation per second, right? So if it's a penny for 10 minutes of work, again, you can do the fraction there and get the reward per second. Reward per second is often so small that it's just not a meaningful unit. So you can work that up into compensation per minute, right? So if it's a penny per 10 minutes, right, it's just basically just multiplying by 60 at that point. If you have it per second, just do it by 60 and get it per minute. That's a slightly larger number. It just makes it easier to work with. But that's how essentially I get these. And then once I got these all for all 20,105 posts, I broke them into 5 categories based on that number. And as we talked about previously, there's a whole chunk of them that are 0 compensation. You see this reward is 0?
Yeah. So
the duration doesn't really matter in those because it's always 0.
It's going to be 0 no matter what. Yeah.
And so those are a special class of thing because, offering someone 0 reward, it kind of says, well, what's going on there? And, I had an intuitive sense after seeing all the data, I guess maybe not intuitive, but a primary sense of what that would be based on the data. And in fact, we looked at some sort of posts last time of people saying a lot of times those 0 compensation ones are like prereqs, right?
Right.
Like you have to do those in order to get better paying jobs.
Right, like a non-credit class that gets you into the other one. Yeah.
So a lot of times those are like prereq kind of things. But that was sort of my sense of it, but it would be best to check that. So anywho, I grouped all the zero compensation ones together under the heading penny, excuse me, zero. Then I also had a separate category for ones that were 1 cent, because they also fit into a strange, I mean, it's the absolute kind of lowest compensation you can provide, even though the duration can be variable, right? I mean, there it's 120. Or wait, that's not 1 penny, that's actually 10. So this is 360. Anywho, so
Yeah.
3600 here. It's again 3600, whatever. The point is 1 penny ones also seem to be a separate class of thing, because it's like the lowest unit. And so, the feeling is this is different than saying, this is compensation, but it's at the lower end of the spectrum. This is like it's like if you looked at straight up minimum wage jobs, right? We're going to pay you the minimum legal thing. That's going to be different than jobs that are on the low end of higher than minimum wage compensation, right?
Yeah, I see what you mean.
I mean,
That sort of, yeah,
a teacher is a low compensation job. It's not a minimum wage job.
right.
You know what I mean? So a
Yeah.
1 penny job, that was a separate category. And those two together, which you'd think, well, that's going to be a small slice. It's about a quarter of them.
Yeah, I would, given what I've been reading, I would suspect it's a big chunk.
Yeah, well, it was larger than I thought it would be. I thought that would
Yeah.
be a special kind of thing, but it's a fair whack of them. So then we have all the remaining ones. And then last time we talked about maybe parsing those up that were, essentially beyond the very minimum compensation into 3 groups, low, mid, high. And I was thinking maybe take the top 10%, make that a group, make the bottom 10%, again, above penny, a group, and then the middle 80%, what we comically called the thick middle. I know you get a kick out of that. Make that its own group. When I did that parsing, that thick middle was, the majority of the data. And so it made the top and bottom 10% a little skewed, and it made the middle a little less descriptive, because you're talking about such a huge thing of data. So it actually made more sense to do the top 20% and the bottom 20%, and then a middle 60.
Okay.
So we've got 5 categories: 0, penny, the bottom 20%, the middle 60%, and then the top 20%. So that's what I did, is I grouped them that way. And I didn't really do this like, I'm not fudging the numbers here where it's like, I was like, oh, what's going to show me what I want to see? I didn't really know. I just knew when I did those, the 10, 80, 10%, I was like, well, this is tiny. It's like that 10% is very small. This 80% is very large. So it was really just, kind of eyeballing the categories. So, all this is to say, I'm not juicing the numbers to try and see what I want. I didn't know what it was going to say on the back end. I was just looking at the breakdown and saying, this is going to be weird. I know. So I did that. And then, so once I got that grouping, I ran what's called keenness measurements. Oh wait, let me switch over what we're looking at. So keenness, and that's KEYNESS. It's basically, it's a thing you can run in Quantita, which is a package in R. I'm sure you can get keenness measurements other ways, because it actually tells you what it's doing. But basically, it's a way to compare a particular set category with another one. So in our case, what I was doing was getting the keenness for each category against the other 4 categories, whatever they were.
Okay.
So you can see here, and you can see this, right? My desktop.
Yep.
Yeah.
Indeed.
So like, 0 keenness is take those 0 ones and then see what's significant in terms of the terms in there in this category against the others. That's all it does. Okay. And you can set that up such that if you want to look at that more carefully, you could do something like set keenness to just do 2 of those categories. Like if we just wanted to compare, the top and bottom 20% there, you could tell it to do just those 2. But the way I had it set was just compare against everything else. They break it into what's called the target and the reference. So, what you're looking at and then what it's compared against. And I had it just a set compared to that, but we
Now,
can, go
is
ahead.
the idea then that comparing one to the other is that to get a sense of how unique those categories might be?
Yes. So let's take a look at what you get. Let me just hide this because oops, that's not what I wanted to do. There we go. There, okay. So here are I got measurements and I got diagrams. Let me show you what one looks like. So here's, and I did it for bigrams, trigrams, and unigrams. Unigram, zero keenness. So this is a diagram that kind of shows you what you see here. So this, if we use the zero compensation ones, you can see these are the terms that are essentially prevalent in this category and are not prevalent in the others. Do you remember when we talked about Frex?
Yeah.
So this is not exactly a Frex measurement, but it's getting at the same thing. What's popular in this and not popular in the others. We'll look at the actual numerical measures here in a second, but it gives you this handy diagram of, you can see it says zero in reference here. So it's counting essentially, these are terms that are super prevalent here, and they're balanced against the ones that are prevalent in everything else.
Okay.
Where you can see in everything else, what's prevalent is, survey, minute, study, complete, questionnaire, these things. Here in zero compensation ones, lo and behold,
it's all the weird ones.
It's the ones that are, what we think are bots, right?
Yeah.
It's bot stuff. And then there are some like Skype interview, and they actually sort of show you brand. They show you, let's drill into those terms individually and see, just do a find. Or, in R and in Quantito, it's sometimes called quick, KWIC, keywords in context, where it'll show you essentially the language around these words in your data.
Sort of where they're showing up kind of stuff.
In the data, yeah. So, I mean, it's really no different than just doing like a find in your data and seeing, what's going on there. But you can see predominantly we've got these sort of bot-driven ones. Let's take a look at just a couple of these other diagrams. So let's look at the top 20. And here you can see the top 20% versus the rest of it. And this gives a better sort of sweep of the diagram, because the 0 one, you'll notice there wasn't a whole lot in the gray bars down here. It looked kind of flat.
Oh, yeah.
Yeah. And they're essentially the reason why there was a kind of leveling of the predominance of those terms in the rest of that whole corpus. Here we can see a better scatter, where this is top 20% versus everything else. And, unsurprisingly, we start to see those automated ones here, because again, this is top 20 versus everything else. Now that everything else includes, but we can also see stuff like Hurricane Harvey, ISIN, which is a financial code thing. What's prevalent in the top 20%? Things like banner ads, compensation, study. Now, and here's where it starts to get interesting. Things like relive is an interesting term for the top 20, because it's going to be asking you to relive traumatic moments, right? Follow up, which if you poke into it, it's follow-up surveys about things like Hurricane Harvey. So some of this, it's like, well, this doesn't seem too informative at the unigram level of, I'm not really sure exactly what's going on in these top 20s. And, potentially that's true, but we can still see differences. Like we can see how mental health, pops up down here.
Yeah.
But like if you start to move into things like bigrams, let's look at the bigram top 20. So now it starts to get a little bit more clear. We see banner ad, we see brand, relive past, right?
Yeah.
So what's high compensation? Some things that are brand focused, but also some things like reliving moments from your past. And that's informative. Sorry, go ahead.
Yeah. No, it's just, this may not bear out, but the idea that there's this, at the top, it's trauma and brands.
Yep. Yeah.
Those are what human beings are, right? If we're getting to the larger scope of our study, what do you need a human for? Whether this brand works and what trauma have you experienced? Those are.
Well, in a way, it's like, well, those are things, machines, a machine doesn't have trauma the same way we have trauma. So it does make a kind of intuitive sense where it's like, oh, okay, yeah, of course, if you want to know about, mental health and wellness and well-being, you have to talk to humans, right? This
Yeah.
is the bigrams of the bottom 20. And you can start to see, so what differentiates the bottom 20 from the top 20? And here you can see these kind of functional things, right? Like looking up ISIN codes, extracting information from shopping receipts, right? Let's see,
Right.
code 4. So this kind of, dare I say it, kind of like mechanical stuff where it's like, it's data acquisition, pull data
Mhm.
out of this receipt, things that kind of ride the border of a machine probably could do this, right? Like is readable.
Right.
I mean, that's a term here, is readable, right? Readable extract. It starts to give shape to what are these bottom 20%, right?
Right.
You really can start to pull, particularly in relief to other things, right? So if this is bottom 20% and in relief to everything else where it's talking about mental health and cope
Yeah.
mental health,
Cope. Your cope. Yeah.
you start to see, oh, okay, so this is what this is not, right?
Right.
The
Oh,
bottom,
I so not. I see what you're getting at. It's not just that they're not included. You can start to see.
this
Yeah, I
is what
lost.
it's farthest from.
Yeah.
Yeah. And so, I mean, if we wanted to, we can get this a little more fine grained by doing something like, let's just look at bottom 20% and top 20%, and then this diagram will look different.
Yeah.
But basically, this is saying, this is what this data is not. So these kind of things of, how it's different from the rest of the data, not what's characteristic of it, but what it's different from, that's really useful. So
Yeah.
these diagrams are actually pretty useful, and they are an encapsulation of these measurements, right? So let's pull up, let's do bottom 20 of the keenness measurement here. So all it is a spreadsheet that gives you some things, right? So we're looking at the bottom 20% in bigrams. We've got the target, and these are just frequency counts. And then we've got the reference. The P we don't really need to get into, but it's a score. This is, you can find keenness using a few different methods. This is the chi-square or chi-squared method, which is a way to determine whether a particular thing, in this case a bigram, belongs within a category. It's a kind of a way to figure out what are the chances that something would appear in this category randomly. And if it's not random, then it's strongly probable that it belongs to that category. There are other ways you can figure out keenness. Chi-square is a popular one, and so it's the one I went with.
Okay.
Quantite, I think, has 4 options there, but again, you can spend the rest of your life just doing these permutations. We just need to pick one and go with it. So right now, this
You
is,
might very well, and you might very well do that.
well, that's the problem. I mean, you just kind of have to go.
Yeah.
And right now they're ranked by the chi here, the chi-square, and you can see it's not just a simple like math problem of target and reference, because notice that like here, all 887 appearances of this particular bigram, ISIN code, they all appear in the bottom 20%.
Oh, I see.
None of they don't appear anywhere.
So that's a really clean.
Yeah. Well, see, and that's what's one of the good things about this being in a spreadsheet is it's ranked by default by the chi-square. You can see this goes down. But if you want to find like true exclusivity, right? So like this is a term that is exclusive to this category. All you have to do is a quick data sort, right? I mean, just do a ranked sort here of, I mean, let's do n reference largest to smallest, and then let's add a level here and do n target. I guess the largest to smallest too. Let's see. So let's see where the break in 0 is. Okay. So here, once we hit 0, those are truly exclusive terms, right? This only appears in the bottom 20%. And so now we can figure out which terms are truly exclusive. And that's not exactly the same as just ranking the chi-square, right? Because you can see if you go just by chi-square, it's figuring out a different measurement of frequency and exclusivity, but it's not like
Yeah.
it's truly exclusive. But that is there. You know, we can sort
Yeah.
by things that are truly exclusive. We can sort just by raw frequency counts if we wanted, which would, I mean, a lot of those would pop up in other categories, but it does give you essentially 3 useful measurements here. Like, let's see if we
Yeah,
just
that's
did,
wild.
yeah, I mean, it's great. If we just did raw
I
frequency
can see why you were. I can see why you were excited.
well, this isn't even the one I was excited about, to be honest with you.
Yeah.
We'll
By
get
the
to
way,
that.
for our audience members at home, I've received several cryptic messages
Yeah,
over the last 2 weeks, and this is all new to me too. So
yeah. They
Jeremy
usually
was
I'll
keeping
send
it pretty close to the vest.
my message, my text to Nathaniel usually are tantamount to, "Oh shit, I think I found something," and that's
Yeah,
it.
basically, no follow up. Just yeah.
But like, so these are just raw count. I mean, and just to put a button on this, so these are just raw frequency counts, right? So like the most prevalent is survey about, but that's just prevalent in the corpus as a whole, right?
Right.
So if you just go by raw counts, it's like, yeah, I mean, that's prevalent in this category, but that's prevalent in every category, right?
Right.
And so it's why something like a chi-square here is a great measurement, because then we're getting, oh, okay, these are very prevalent and relatively infrequent in other ones, right?
Yeah.
Even though this has
Yeah.
300 appearances in the rest of the data set, it's got over 1,000 in this one, right?
Yeah.
So shop receipt is pretty strong. I mean, numerically, it's not
Yeah.
just us saying, hey, that seems pretty strong. Just do the math,
Yeah.
right? I mean, it's the second
Yeah.
most. Yeah. Anywho, so these give us really useful metrics. And I think the good news is those diagrams are like a nice digest of this, right? Because they're just giving
Yeah.
you the chi-square measurements. And they give you basically the top and bottom of this, right? So like in that diagram, it gives you these, I think the top 10 or so, and then it gives you these down here. Like, remember how compensate and survey were strong down here? Because it's basically just giving you the top and bottom more or less. Yeah, so actually let's make this practical. Yeah, so we got compensate hit, 1 minute Hurricane Harvey, and you can see if we go down here, it's duplicated here, because these diagrams
Right.
are just giving us the top and bottom, because that's telling us what's most prevalent in this category, what it's farthest away from.
So if you go back to the sheet, just from my own edification, like you can now see that where there's a 0 for Hurricane Harvey for the set, and then like it's the flip of when you
Yep.
saw it only in that category and 0 in the referent. This is now
There's 0 in this category and over 2,000 everywhere
it
else.
only exists. Yeah. Okay.
Outside of, yep. It only exists outside of this. But you'll notice, even though it's 0, it's not the very bottom, right? Because the very bottom, there's 26 occurrences of compensate hit in this category, but there's over 2,800. See? So it's not just a simple division of,
Right.
this number divided by this number, because otherwise you'd be dividing by 0. Chi-square doesn't just do that division.
Right. That would not be helpful.
Right. And so, but it's precisely for these kinds of problems, right? How do you get a measurement of frequency and exclusivity in cases where you have 0? So you can't just do multiply or divide, right? Because it's
Right.
rational, or you get 0. So you have to figure out a way to do that. And that's what this measurement gets at. Anyway, so the good news here is this. What we wanted to do was try and find out if we break these into those compensation categories, right? 0, penny, bottom 20%, middle 60%, top 20%. Can we then look inside those categories and see, all right, well, so what's characteristic about this category? We can, we've got it.
Yeah.
We've done it, right?
Yeah.
So what's that? What'd you say?
We're done.
Well, I mean, we've got our results, right? Now we just have to interpret those results, right? I mean, that's how this works. Are you still there? You're frozen.
Yeah.
Okay. Okay. You're just frozen. That's all it is. So what we can do is,
Right.
I'll post this data, I'll share this data, but we can go through these and then figure out, oh, okay, so, what is characteristic about these categories? Um, and I did it, as I said, 5 categories: bigrams, unigrams, bigrams, trigrams, because that matches our frequency stuff. And actually
Yeah.
stepping up into bigrams and trigrams, I found actually is pretty useful, because you start to see words together that, reiterate, as we saw with those bigrams, things like, relive past, right?
Yeah.
That's more informative than just relive. You might not know what relive is, until you
Now,
start to see them together.
which is interesting because, as I recall, maybe this is my own psychological or emotional response, that
Oh, shoot, you
whenever
dropped
we
out.
decide to categorize them this way. Oh, am I here?
Yeah, go ahead, start again.
But I think what just sort of thinking about the way I was thinking about this before we broke them up into these compensation categories, that I found the trigrams and the bigrams a little, I was sort of skewing toward unigrams as the thing I could kind of wrap my head around. And now when it's sort of understood this way, I'm making more, I'm less intimidated by the bigrams and the trigrams,
Yeah.
if that makes sense. I have more purchase on them now in this context.
And they are actually kind of useful, and statistically, because there are lots of ways to try and get information out of a corpus. And curiously enough, just things like frequency measurements of bigrams and trigrams are pretty darn good. I mean, they can often, in often cases, beat more sophisticated things like, topic models. Just frequency counts of bigrams and trigrams can actually, in some ways, I mean, they hold their own, if not are superior to what we consider later, more sophisticated corpus manipulations. Even potentially things like word embeddings or word vectors, which are more recent and more sophisticated. In some cases, just these stepped up, n-grams can be super useful. I mean, look, our COPE mental health, or your COPE mental health, that is, that's pretty darn specific,
Yeah. Yeah.
Anywho, so we've got these, we can go through these,
Well,
go
real
ahead.
quick before we even move on, I'm even noticing that now with what you just pulled up, that instead of getting Hurricane Harvey, we're getting after Hurricane Harvey.
Yeah.
That trigram, then what the trigram adds is it puts a temporal, it adds the fact that Hurricane Harvey, when that bigram is appearing, it's actually part of a trigram that's, I mean, it's probably not surprising that it's after, but still that adds something to that.
It shapes, okay, so what we're talking about is, in the wake of Hurricane Harvey, give us this. And in fact, if you drill down into those words, because you can just do finds, that's basically what it's talking about is, reliving moments after Hurricane Harvey. It kind of fits into that trauma category that we see also with PTSD and cancer. That's another kind of interesting one. Cancer, you might say, well, what's that one about? If you drill into it, it has to do with, cancer survivors and surveying them about their information. If you remember that thing we looked at last time, which was just sort of that popular periodical thing about, Mechanical Turk paid me a few cents to live the worst moment of my life.
Well, it appears your data bears that out, that was in the higher range of compensation.
Well, it's interesting even to break out, because I think the Hurricane Harvey is principally in the middle band. That's the kind of interesting thing, is where you start splitting them up into high, mid, and low, and even a penny, because it's kind of interesting where this for me is interesting, because I was kind of curious and looking at particular terms. I was looking at what was it? It was transcribe versus summarize.
Yes, I remember that.
Because you'd think summary is a more cognitively intense act than transcription. Is that borne out in your compensation level?
Right.
Anywho, So we've got those. What we can do, and I mean, I'll be doing this, and it's it's something we can do going forward. Is take a look at this data and tease out, okay, well, what are the differences between these categories, right?
Right.
So that's a step there. And let me just share this. There we go. So this kind of stuff, let's see, yeah, kind of fits into this part of the outline, where we've categorized by compensation tiers. In fact, I need to update this. And then what do we see in there? And primarily we can use these keyness measurements to do precisely that. In fact, as we go here, I think it's going to make more sense to kind of break our excuse me, our findings into a different parsing here. I'm thinking probably what's going to make more sense is this. Start with an overview, because there's part of me who says, oh, okay, now that we've got these keyness measurements and what we can do with those, the previous stuff where we're looking at like overall frequency counts of the entire corpus, looking at, as we saw last time, those when we did the clustering and topic modeling with a K of 5, if you remember that. And then I was going to go forward and say, I'm going to do STM at a K of 20 and try and get a more, individuated sense. So I was, part of me was like, well, we don't need that stuff. We can just throw all of that out and just start with the keyness findings. We categorize by compensation. But what I was finding was there wasn't really a context to plug what you found into, right? So, I mean, if you say, okay, this is after Hurricane Harvey, and this is talking about transcription or whatever, there wasn't really a broader context of the thing as a whole to plug those things into.
Right.
So I'm thinking now, probably the way to proceed is this. We start with an overview of the corpus, and that's going to rely on what we see in the frequency of unigrams, bigrams, trigrams, a scattering of the stuff we ran that gives us a little bit more information than the frequency measures about here's what the corpus is, doing the K5 stuff.
Right.
And then last time we talked about doing STM at a higher K, probably 20, because that's what the diagrams kind of said. There's breaks at 5 and at 20. If you remember,
those are the elbows.
The elbows really strongly showed 5, but some of the other measurements showed after after 20, the data got asymptotic. It got sort of odd. So there was something at 20. Now, the thing of it is, while I was poking around and doing that, because you'll remember when we look at what we get from STM, you don't just get frequency. You get 4 measurements, right? Frequency, frex, which is useful. And then score, and then another measurement, which I can't remember, but those other measurements are kind of, again, trying to get at not just what's frequent, but what's characteristic. That's why something like why the frex is so good. The problem is, and I can probably make this concrete by pulling these up. Let me see here. Is this it? Yeah. So just to make this practical, this is what I'm talking about here, right? So this was when we were doing the K of 5 through a bunch of different ways. And when you do an STM, it gives you this, right? Frex, lift, and score. And so this is for a K of 5. If you bump that up to 20, it's a lot of stuff. I mean, what would that be? 80 lines to look at?
Right.
And so it's a little tough to get a handle on what's going on in categories, just because there's a lot of stuff. There are a lot of threads to keep an old duder's head when you've got 20 of these, 4 measurements each, right? I mean, bless you. It's more fine grained, but it's like, it's a little tough to figure this out. So anywho, I was poking around for other ways, because what we want to do here is basically just sort of get a sense of the threads inside this corpus. That's really what we're
Yeah.
doing here.
Yeah.
And so I was poking around, and this is why I texted you. I think I've found something. I found this package that lets you do this in kind of a really useful way. Let me pull this up. Okay, so you're seeing this visual right now, right?
Yes.
Okay, so what you're looking at is our data with a K of 20. And what you can see here is it's broken these categories up. And do you see how some of them overlap visually?
Yeah.
So what it's showing is, hey, those are probably linked, because in terms of the stuff in there, they're pretty similar.
Right.
And if you want to take a look at one particular category, all right, so let's click on category 13 here. This is showing me, as you can see, overall term frequency is this blue bar, right? So
Okay.
study. The reddish bar is estimated term frequency within the topic. So study is pretty prevalent in there. It's super prevalent in the corpus as a whole. I can take this slider up top and I can move it, and it starts to shift the balance such that it's skewed more toward the things that are exclusive to this and less towards the things that are in the corpus as a whole. So as I slide it over, notice that things like study, which is just straight up the most frequent, but it's also super prevalent in the whole corpus.
Yeah.
As I slide it over, it starts to drop, because now we want to know what's prevalent in this corpus, in this category, not what's in the whole.
Not, yeah.
So as I slide, notice that the red bars start to stretch out, because we're looking at what's prevalent here, not what's prevalent in everything else. If you go all the way over here, this is pretty much, what's exclusive or super common in this category, right? In fact, there are some, you can start to see, like down here on security, notice how there's a little bit of blue, right? Which is saying it's mostly in this category. It's a tiny bit in the others. And in fact, if you want to know where else does it appear, slide over to security and it shows you category 13 and category 20. And this is their proportion, right? Mostly in 13, mostly in 20.
Yeah.
So like if we wanted to look at something like, study here, let's just slide over there. Here's all the categories scaled where it pops up. To me, this is like, holy cow. I mean, the control this gives you to find things that are similar, right? Because that was our problem. Like once you've got categories, once you've got 20 categories, how do you collapse them together, right? Because we want to see, 20 categories isn't useful. We need fewer categories. How do you fold them together? This shows us these categories are linked, right? These categories are linked because they share stuff. And we can even drill into, things like, well, here's cancer. Where does cancer appear? Only in category 13, right? Excuse me. You still there or did you drop out? Oh, crap. Yep, there he went.
Okay, I'm back.
There you go. Okay. Anywho, so what I was saying is this gives us a way to knock down, those 20 categories into fewer categories without just sort of relying on what it feels like, right? We can see similarities here. We can see clusters. We can say to ourselves, why is 2 miles from everybody?
Yeah.
Oh, because 2 is that weird bot one.
Yeah.
See, if we look at the exclusive ones, look at what it pulls up. Things that are, truly exclusive to it, right? Let's see, turns, no. Here we go, match. Match also pops up a little bit in 20, 14, and 6. But I mean, like everything else is just this. So it's like, oh, a visual representation. Yeah, these are weird because they're the machine readable ones.
Yeah. Now, maybe you have, or I'm not quite getting it. What are the axes here? Like what's?
Yeah, I can't really give you an explanation for what these axes are.
Okay.
I'd have to look into that further. Yeah, I mean, it's a good question because it's like, well, what's saying these are similar? And the answer is, I don't really know.
Okay.
It's saying these have overlaps. It's up
Right.
to us to figure out what those are, right?
Okay.
Why is 3 here a subset of 1, right? I'd have to dig further into what PC1 and PC2 are, because that's what's being mapped. But
Right.
honestly, I'm not entirely sure, unless it's potentially this saliency and relevance down here. I mean, that's probably what it is. Do you see down here?
Okay.
But I mean, it's giving you the algorithm, but it's like, okay.
Right.
I mean, yeah, it's the sum times the log, and then it points us to some literature here. I suppose that's what the axes are.
Okay.
But yeah, I mean, I've still been kind of digging into what this is. So to me, this was useful because it kind of takes the place of what I was gonna do with those STMs, and it makes it visual, right? It
Right.
allows me to see, okay, these two things are clustered together. What's making them similar? Are they a unified thread in the overall corpus, right? It visualizes what I was hoping to get out of doing those K20 STM runs.
Yeah, because now we can kind of look at it and sort of see how they're sort of visually or even physically located relative to each other.
Yes.
And so is there then some of these clusterings that potentially that's where the uniquely or not even uniquely, but primarily human kinds of labor are to be found?
Yeah. And potentially you could even maybe do things like, even without knowing what these axes are right now, 2 is furthest from these, right?
Right.
So in what ways are these 2 categories dissimilar from their opposite here, right?
Yeah.
I mean, and that's the thing is, whatever we can say, so what is this mapping? Whatever it's mapping is numeric. It's not the case that there's some secret semantics here that
Right.
we don't know. The answer is almost always, well, what do you see? Right? I mean, it's giving you a numerical score. It's saying, well, these are linked. How are they linked? The computer can't tell you that.
Right.
We have to, I mean, we're the ones doing the interpretation.
Yeah.
So this is pretty cool. And here's the part that I think is even more exciting. So what we're looking at right now, this is in a browser. I have this running on a web server. What this means is we can post this as our data, with our data,
Yeah.
and give people not only just those raw,
But they can
do this
with the sliders and stuff. Yeah.
Yes, they can do this. Now we have to set the Ks, right? This is a K of 20, but we post this. I mean, look, this is just running on my web space right now, my school web space.
Yeah.
They can do this stuff themselves. And if we find things we want to point out, like, oh, holy cow, here's memory. I like that. So what I'm gonna do is, let's see. So it's got term memory there. Term memory. You can actually just put a URL in and it gives you this display.
It will take them to
precisely.
Yeah.
Yeah, you're getting it. Yep. Once you find something you like, you can just share the URL and it pulls that up. It still can be manipulated,
right?
But it jumps to that.
You can get them to land where you want them to land.
Yeah. So instead of just like taking a screenshot of this and embedding it, we can actually have the thing there.
Right. Now, can you embed this? Or would they have to come to this page?
I'm betting Manifold will give us the ability to embed this because I mean, you can just do a simple HTML5 embed.
Yeah.
And I'm betting it'll embed. I mean, we'll figure it out. But I mean, that to me is why I sent you an excited text, because it's like, this isn't just something you and I can look at. This is a tool we can give people to sort through the data themselves.
Right. So it's not just, we're not sharing the data we have as, a series of spreadsheets. We can also then share a manipulable set of what we've collected.
Yeah. And I mean, we can give them stuff that won't even make it into the paper, right? Because this is all unigrams. What if we did it with
Right.
bigrams and trigrams and those ended up not being used, but the tool would still be there? So in
Right.
theory, other people could come behind us. Now, the one caveat is you do have to set K. It'd be awesome if you could somehow tell it to change the K from, 5, 6, 7, 8. The problem is the way this works is you need to set the model first, and then
Right.
it's making this visual based on that model. So there's no real way to do that. You'd have to do one for each level of K and then tell it to. I mean, there's a way you could do it, but this doesn't do it. But it's still a really neat, it's not a display, it's a tool, right? It's
Yeah.
not just a diagram. Hey, here's an example of what we're talking about. Here's something you can use to dig into this data. And I think that's really neat.
Yeah. No. What's the does this tool have a name? I was just going to add it to our feed here for Twitter.
Yeah, it's called LDA-VIS.
LDA.
LDA Viz. Where that's coming from is LDA. That's a topic model technique, latent Dirichlet allocation. And then this is Viz, VIS.
Okay.
And the code for it is on GitHub here. And you see it's a couple of years out of date. So I was a little worried. I was like, oh boy, I wonder if this even works anymore. But it does work. And I believe it was done by, yeah, see, it says CR paper, which we presented at the 2014 ACL, right? So it was kind of like a scholarly tool that they then put on GitHub, but I think haven't really developed much beyond. Let's see, where do the issues go? Yeah, so I mean, there's still people posting issues, which means people are still interested in this, but they haven't updated the code for a little bit.
That's awesome.
I wondered if this came out of UC Davis, and that's also why it had that name, but maybe not. Let's see, what is their paper? Iowa State, AT&T Labs Research. So there is this brief, 8-page write-up about it as well. I think it was, a conference talk.
Okay.
Yeah, proceedings of the workshop on interactive language learning, visualization, and interfaces. Association for Computational Linguistics. No surprise there. Anywho, so that's what I was kind of torqued up about. Now, I haven't gone through this, and I need to tweak that tool because there are lots of ways to make an LDA topic model. The way they use is not the way we like to use. We like to use Quantita, which is it's a package in R that stands for quantitative quantitative text data, I think. Quantida.
Okay.
Quantitative text data. Yeah. And so it gives you the ability to do all these manipulations. I want to be able to build our LDA using Quantita and then fold it into this kind of visualization. The tutorial they have uses a different mechanism, which you can follow, but there are just some quirks to it. So I'm going to play with this a little bit to get the tool the way I want it to be. And then I can kind of process, oh, okay, so where are we seeing clusters, whatever. So what that's going to do for us is, again, this sort of first move in our findings. I think what we're going to do is when we start talking about methods, we're going to start talking about how we collected the data. Then when we move on to findings, we're going to have to go through, as I see it, 3 steps here. First, where we're talking about an overview of what the data is, and that's going to rely on the frequency counts, the sample clustering and topic modeling at K through 5, which we've already done, and then digging into the data with the LDA VIS, and maybe, because I haven't run these yet, maybe running some network diagrams, because that's another way that it gives you a sort of clustered visual about terms. It's just another form of trying to get a handle on what's in the data. And so this is the overview. Now, as I said, I think this is probably going to be useful to do this. There's a world in which all of this could just be deleted, and we just start with this categorizing by compensation tiers dig into the keenness measurements we have and start identifying it and go from there. There's a world where that makes sense. And I mean, that could still be the way we go. It's just, I
Yeah.
say, as I was doing this, it felt like I needed a larger overview to plug the things I was finding in the keenness measurements into.
Yeah.
So I think this will be useful to do this overview. I'm not certain, but I think it'll be useful. Then the last move after the sorry. I think the last move, once we find things in keenness, is to move into specific terms, right? So once we kind of see through unigrams, bigrams, trigrams, these terms and phrases that are important, then we zoom into those things themselves in context, but then we can also do things like what are called word embeddings or word vectors. And really what those are is they're predicated often on skipgrams, which means they're like bigrams or trigrams, but instead of just saying these words come together, you basically take a window and you say, all right, I've got a word right here, right? Dog. And I'm going
Yeah.
to look at its proximity to everything around it for, let's say, 4 words on either side, right?
Okay.
So here it says dog, here it says dog, ran. And then I'm going to do that for every word, going out to a range of about 4, and I'll get a numerical measurement based on how close it is to all of these. Then I'm going to move on to the next word and do the same thing. So that's what word vectors are, skipgrams. Often, I mean, that's not precisely true, but it's coarsely the case. And that gives you a way to kind of drill into terms beyond just their immediate proximity. That's really all it is. But you can do things like look at sort of the numerical similarity of particular terms in the corpus. You can measure things like, you can look at units as, are they mathematically similar or dissimilar? I mean, the thumbnail example of word embeddings has always been, you train it on a corpus of text, and then you can do things like say, because you can do math with them because they're numerical. You can do things like say king minus man equals, and it'll give you queen or something like that, right?
Okay.
Because even though it doesn't know what those are, it knows enough math about the corpus it just examined to understand that relationship, that removing man from king gives you a queen.
Right.
So I think we might want to, once we do the stuff with the keenness, things that we've already got, we might want to zoom into specific terms and words. I was pointing out the difference between transcription and summary. That's an example.
Yeah.
Right? What are the differences there in context, in similarity, whatever? So if you think about it this way, what we're doing is a zoom where we start at the broadest level. Here's an overview of the corpus. We then move into a tighter level of categories within the corpus based on compensation. And then we zoom into the most tight level of sort of word differences or phrase differences.
Yeah, and I wonder if that summary versus transcription would be an interesting like test case. I mean, like a kind of, that might be a if we've got a, not like we have to pick one, but that might be just an interesting one to take as the kind of first one to think through.
Yeah, I mean, that's the one I was gonna, and we might see other couplets in looking at this, the keenness stuff or whatever. We might just find other couplets that we think, well, is there an illuminating difference here? And some of them there may not be. There may not be for transcription and summary.
Right.
I haven't really drilled into it, but those popped up, and I was like, that might be educational to see, because it feels like summary is a cognitively different task than transcription. How is that reflected?
Right.
Or is it not? Anywho, so those were the kind of the two things is we've got the keenness measurements, and we have that LDA vis, which I think gives us a handle on sort of the thing as a whole, at least a way into it. I know this looks like a lot, but really we've done most of this stuff.
Yeah.
I'm gonna, I'm gonna tinker with the LDA viz stuff. I'm probably gonna run some network diagrams just to see if there's anything there. If there's not, then I just won't use it. Um,
Yeah.
and then I need to zoom down and do these. Now, when I say do them, like we've got the findings, we don't have the interpretation, right? So
Okay.
once I get all
Okay.
these findings, you know what I mean? I mean, I've got those spreadsheets, but I haven't poured through them or anything. And I mean,
Yeah.
that's often how social science proceeds. You get the I mean, in the standard IMRAD structure, right, of intro, methods, results, and discussion, they pointedly parse up results and discussion. Here's what we found. Here's what we think it means.
Right. Right. Right.
We've
Right.
got what we're mostly getting. Here's what we found. We don't yet have discussion of here's what we think this means.
Yeah. Yeah.
So anywho, I can wrap this stuff up, pretty soon, and then we'll just draw a circle and say, all right, we've got all our results. Let's
Mhm.
now interpret them. Okay.
Yeah. I got nothing.
Well, so you identified some books that might help us, right?
Well, I think I mentioned them last time. There was the heteromation book, which I think I was just digging into. Um, and that ended up being useful in part because just the concept of heteromation was useful way for like coming up with a larger term that would incorporate something like mechanical Turks, but allow us to, right, if what we're trying to impart do is identify some kind of cultural technique of which mechanical Turk is a part or taking place, heteromations maybe is that because in in this book they see mechanical Turks as akin to like ATMs, self-checkouts, but also the ways in which video game companies use modders to improve the product, the ways in which moderators can be used to clean up the reputation of League of Legends, that. So there's these kinds of things that are either, which is why the zero compensation thing, that's why I thought it might be. I mean, if we had instincts, I figured it might be bigger than we thought it would be, in part because how much of this heteromation is monetarily uncompensated work. And in fact, that's in part the value of it. Because one of the things that they're working through too is this idea that automation is replacing human labor. And oftentimes it's not, it's just moving it around, right? So the idea that a ATM replaces the teller, right? So that a human being loses their job to an ATM. But all the ATM does is it's a machine that then transfers that labor onto the customer, right? So it's not, a human hasn't lost their job. A human has lost their job to another human, right? So all it's done is move the human labor around. It's not replaced it. And often
there are particular economic reasons why, because when that labor is pushed to the user of the ATM, they're no longer paying a cashier.
Yeah. And oftentimes, right, if the ATM is out of your bank's network, you're paying for you're paying to be the teller. And so that's kind of interesting way too, in which the labor gets, the machine isn't replacing a human. It literally is like hyphenating. It's replacing. It's putting the human someplace else.
Relocating.
It's relocating the labor. But a lot of that ends up being not compensated because it's oftentimes under the guise of, automation, which might work for some people, right? If you're agoraphobic, I don't mind being the teller because I have a hard time making eye contact with strangers, but anyway, so that gets at that. But then they've also got this, when they go through their examples, they break it up into different kinds of labor. So they've got cognitive labor, creative labor, emotional labor, communicating labor, and organizing labor. So they've got this sort of categories of different kinds of labor, and then looking at what kinds of heteromation you go to for those kinds of labor. and so what's interesting is they don't necessarily identify it in terms of things that humans are good at and things that machines are good at. Is that here's different kinds of labor,
Hmm.
which results in different pairings or arrangements
Yeah.
within a heteromation.
Interesting. Yeah. So, I mean, in
Uh,
theory, we could potentially map some of what we see to that structure, right? Of
yes, yeah,
emotional. And yeah. Okay.
yeah, and that gives us, I think, purchase on some of those things that we're seeing, right? That we can see the kind of relive Hurricane Harvey
Yeah.
um, as a kind of thing, and the brand thing might be a kind of cognitive or even creative labor, right? So
Yeah.
the ways in which I mean, they even see heteromation as things like design contests, where like you
Mhm.
want to rebrand something, but you open up the rebranding, so rather than paying a firm, you
Yeah.
know, you pay someone $100,000. So it looks like, right, the winner of the prize gets $100,000, but you've basically paid $100,000 to get 30 pitches.
Yeah.
You don't have to bring in now Don Draper 30 times,
Right.
you know. Um, and that's a way of parsing creative labor in the context of heteromation.
You
But
know
I'm
that.
thinking that those 6 categories might be useful for us to then, once we've divvied them up compensation wise, is there a sense in which the ways in which Mechanical Turks divvies these things up in terms of compensation, what ways does that map onto the different kinds of labor categories that the concept of heteromation generates?
Yeah, and that will relate to some of those other tools we found, like Fiverr and some others are
Yeah,
precisely what you've described, where it's like, I need a new logo, and you get back 99 examples of that for,
yeah,
your one flat fee or whatever it is there. Um, so that might be interesting. So what I'll do is I'll share the spreadsheets and the diagrams that I have, right? And you might look into those and see, how like what's going on in the zeros, the
yeah,
zero compensation, and see, because I mean, it's possible that even when we're doing this overview stuff, we might be able to use that framework, descriptively to say, okay, here's what we're seeing in the corpus, and how those map to these heteromation categories. You know what I mean?
yeah, yeah,
I mean, we could, in theory, even start to use that as an interpretive framework for here's what we're seeing in uh, the thing as a whole, and then break it
right.
into compensation and see,
We
okay,
may
now
not
how
need
is that compensated? Sorry.
Yeah, we may not need to wait until the sort of the end to impose it, but maybe weave it through the actual
Yeah.
work, so we're not sort of adding it in after the fact.
Yeah. So, I mean, as you're reading that, I'll post that stuff, and you might just look at the data there and see, I mean, how does that square with that kind of framework?
Yeah,
So let's see, that was that. I think that was, yeah, I think that's all I had to say, really.
yeah. But yeah, those will, I think they're at least, whether or not we end up using them as categories, I think that those categories will be useful kind of as a tuning mechanism for us.
Yeah.
So it may not necessarily be the way we organize it, but it might be a useful way of being an interpretive mechanism, right?
Yeah.
That I, at least early on, I'm going to flag this as emotional, flag this as creative, flag this as
Yeah.
cognitive, and then see if we're seeing the ones I tag more as emotional labor tend to be the ones that are then in that top 20
Yeah. Yeah.
category.
No, I think that'll be useful. That'll be because it'll ground, um, yeah, it'll ground what we're doing, so we're not just saying, well, these are in this category. Yeah, but what does that mean?
Right.
You need to have some framework to say, well, here's what that might mean.
Yeah. And also, just when we go to write this up, it'll be useful to have these working definitions already,
Yeah.
right? We can just point to this, like we are using
Yeah.
their notion of these kinds of labor.
Yeah.
It's saves us work on the back on that end.
Yeah, and it taps into existing frameworks. I mean, one of the banes of scholarship is we keep it reinventing our own,
Yeah. Yeah,
here's the thing we've come up with. And it's like, yeah, but we should be plugging into existing frameworks as much as possible in order to expand knowledge. I mean,
yeah.
that's why we do research. So,
These are already thoroughly developed workable categories. Let's just use these
yeah. Now
as
you,
as
what's
scholarship was intended to work.
right. Yeah, particularly, I mean, as far as I know, particularly on kind of the humanities side, where it always seems like we're inventing whole cloth what we're doing rather
Yeah.
than, applying Smith and Jones's thing to this. So,
Yeah.
anywho, I also noted you sent me this book, Metadata. Have
Oh
you
yeah.
cracked into that?
That's I've just read the opening part. It's from this. I just get these because they're kind of they're not fun reads, but they kind of are fun reads. This MIT does these series of small
Yeah.
books. So I've used them before. Like other one I'm reading is there's one on sexual consent, which is pretty useful.
Those aren't the object lesson ones, though, right?
No, but they're kind of similar, but more, yeah, similar, but not that the object, right? You get a little more of the history of it. So I've not gotten it for, but it's got some interesting breakdowns of the different kinds. That essentially what I find useful, at least early on, is that he breaks down different categories of metadata based on how it's used. So it's, metadata that's used to describe, metadata that's used to administer, metadata that's used to structure, and metadata that's used to preserve. And so, kind of useful ways of thinking about. So it may not necessarily. I was just looking. Yeah, there we go. There's some
The
pretty.
Essential Knowledge series.
Yeah, my students in my new media writing class, we read the drone one, which is pretty excellent. So yeah, but I'm thinking that I mostly picked it up because I like these and they're fun reads, and I figured I would read one that might be somewhat related to this project. But maybe even thinking about metadata itself as a kind of heteromation, right? That metadata is a kind of way of structuring thing, but it needs, it needs a human to kind of complete the loop of what metadata does, because it's not usable in and of itself, right? So he kind of opens up with the various leaks that, the NSA was gathering all the metadata, which sounds bad and probably is bad, but it's also not the same as the recordings of the phone calls, right? For that metadata to really, just having raw metadata about someone's phone calls, you can't really learn all that much unless you really, you got to then do something to and with that metadata to make it do something.
It's a relevant conversation because, that kind of stuff comes up where, I mean, as you say, things like, well, location, you had a phone call because they can track your records that, is this long and it happened at this place because we know where you are because of cell phone, triangulation essentially.
Right.
And so there is understandably, fear about that kind of thing, but that is interesting. What counts as data and what counts as metadata, right? You don't have the call, but we know you were here at this time and we can follow you.
Right. I mean, you kind of see them in crime shows, right? And then you were on the phone for 3 minutes as opposed to 10
Serial.
seconds, right?
It's serial podcast.
Yeah, you didn't call and hang up. You must have talked about something. Well, I'm kind of getting into the part where he's, and admittedly says this is all sort of fuzzy, parsing out the difference between metadata, data, information, knowledge, right? That whole continuum. And that I think also bears on potentially the human non-human divide, right? That you can get a machine to do data, but you need a human to make it information. Or maybe you can get a computer to do information, but the human is who makes the knowledge, right? So it may be that parsing out the difference between metadata, data, information, and knowledge is also simultaneously doing something anthropological in terms of, right? That it may be the difference between information and knowledge is the difference between a human and a non-human.
Yeah.
Right? That's one way that some people parse that distinction.
Yeah, and I don't know if our work will go in this direction, but I remember early we were talking about literacy, and how I had the talk about human beings, a potential shift we've moved into in literacy is we're no longer the readers primarily, but the read, right?
Yeah.
We are now the symbols to decode rather than the ones doing symbol decoding. Metadata is kind of interesting to that because it makes human beings, not just human beings, but it certainly makes human beings readable, right?
Yeah.
The machines are reading us. We are the text. Anywho,
Yeah.
well, yeah, we should probably sew things up. But so in terms of next steps, I'll go ahead and post that data on the site. I'll probably do it today. I'm in class, but I'll post that. If you want to, comb through some of that, as you're looking at this, we can
Yeah.
start to see how the preliminary results might map to an interpretive framework that you've got.
Yeah.
And then I'll proceed with getting results in these different ways. I got the network diagrams. I want to tinker with some word embeddings in that LDA viz, but we're getting results. So
Yeah. No, I think and that tool I think is going to be useful, I think, for us. But again, given our kind of approach to this project, it's a tool that's also really helpful for the ways that we want to do this, publicly and
yeah,
involving people. That it's a
yeah,
way that it may just be that making our data publicly available it doesn't quite drive the collaboration in a way that making your data publicly manipulable
yeah,
or
we're the tool, right?
yeah, that I think that's much more in line, I think, with what we're doing than just sharing it. I don't think that necessarily, as far as that may have got the job done a while ago, but I think that's less unique, I think, than presenting your data that's been somewhat organized, right? That we provide the K, and then
Yeah.
so it's still a kind of, yeah, that's all I got.
Oh, yeah. So I guess that's where we go from here. Anything else?
No.
Okay. All right. Well, I'll move forward with that stuff, and we will talk in a fortnight.
All right.
All right.
All right. Well, good work, and I'm glad to now know what those cryptic text messages were about,
Yeah, that's how I get excited.
and you're sharing that excitement, and I appreciate that.
All right. I'll see you.
All right.
Take it.
Bye.
Bye.